Yeah, I think you guys hear me now. Yeah, great. Now you can hear me. So I'll start from the beginning. All right. Hi, everyone. My name is Nehama. Welcome to the second session of Mastering Landscape in Revit, where I try to teach you everything I know about doing landscape in Revit, especially with environment tools, but not only. Today's session, we will talk about variable material, which is a topic that you guys suggested. Some of the other viewers from last week suggested it, and I thought it's a great topic to talk about. So it's going to be light and breezy today, and we're going to talk about variable materials. So if you have any other suggestions on topics that you would like to learn more about, whether it's environment for Revit tools or anything that has to do with Revit and how we do landscape in Revit, you can leave a comment or write it in the chat. And today I'm all by myself, so hopefully I will be able to also see your questions and answer them as I go live. And hopefully you will enjoy and find value so we can continue this thing from week to week. What's my name? My name is Nehama Shechter-Baraban, sorry for not saying, and you can find me on LinkedIn and on our website as well. So I think without further ado, we can jump right into Revit. And actually today, first of all, you can see that I am within Revit 2024 today. And before I start to talk about today's topic, which is variable material, I thought it will be really interesting to show you a question that we got from one of our clients and to just show you how I solved it. So last week, one of the topography tools that I showed you was the insert midpoint, which is kind of interpolating. And this is, I think, a perfect example of how to use this tool. So the client that sent me this Toposolid, basically what they did, they created 3 model lines, 1, 2, and 3, and then they used environment topography tools to create the Toposolid from that. So if we select the Toposolid and go to the Modify tab to edit this Toposolid, you can clearly see that the elevation points are laid on top of what used to be these model lines, right? But then you can see that I have these strange gaps over here, and that's really not what the designer meant. They wanted to get a very smooth result. So the reason why these things happened, if I go to the visibility graphics menu and turn on the folding lines in the Toposolid, you will be able to see that this is where Revit kind of decides how to connect the points. And this is why these things sometimes happen. No, not the split lines, it's the folding lines. All right, so this is why these things sometimes happen, and this is where the insert midpoint tool is really helpful. It's kind of interpolating or adding the missing information that Revit needed. Let's go to insert midpoint, click on this point over here, this point over here, click on insert points, and you can see that immediately Revit can read this shape a lot better. Let's do it again over here. And you can see that I'm not moving the density slider. I don't even need to add more points. I'm just taking it all the way down and letting environment for Revit optimize the amount of points for me. Let's click on insert points again, and let's do it here again. So this is one of these classic cases where environment tools can really, make your work easier. You don't really have to calculate. You don't really have to understand how Revit works. You just use this tool. This is what it's here for. And this is just one of the examples where this tool can really, smooth out the topography very easily. So that's, question for the crowd, and that's an open invitation for you guys. If you have a question, something that doesn't work, and you don't really understand how it's working, you can reach out to us either through the Arc Intelligence website. You have a contact us form, or in LinkedIn, or whatever platform that you want to reach out through, and please send us questions. We love a good challenge. So now for today's topic, which is variable material. All right, so what is a variable material? First, before I start, I want to remind you that a toposolid and a floor work pretty much the same. This is a type-based solid element that is made out of material layers. So if I click, for example, on this toposolid and go to the edit type option, let's open the preview. Let's make this window a little bit smaller. Let's go to the structure, and you can see that I have different materials in different thicknesses. Each of them, all of them together create the overall thickness of this type. And over here, I have the option to either make a material variable or not. In this type, none of the materials are variable, but over here I have a similar type. Let's go to edit type, structure, and you can see that one of the materials is variable. So in short, what does it mean? When I have a floor or a roof or a toposolid, I define the elevation with the constraint over here in the properties. So the elevation over here is sea level, which means that this elevation over here, that's the sea level. And this elevation over here, that's the sea level minus the thickness, the overall thickness of the floor. Now, when I have a floor without a variable material, or a toposolid, whatever, I can go to the modify sub-elements, change the elevation, and this is the result that I'm going to get. But when I have a toposolid with a variable material, I can go to the modify sub-element, change the elevation, and this is the result that I get. So overall, this image over here is the best explanation of what is a variable material. The nice thing is that you will find variable materials in floors, for example, in roofs, and also, and this is really nice, I don't know if you guys knew it, but you also have variable materials in walls. So, oops, I created this wall outside of the section box. So let's take the section box off. And now let's take a look at the wall that I created. So why would I have a variable material in the wall? And that's outside of our topic, but I thought it would be interesting. If I go to the walls structure, and just for the example, let's put another material over here. Let's call it concrete. And let's make the structural material variable. Click on OK. It can't be 0 thickness, so let's make it 10 centimeters. So now I have two materials, one is variable, one is not variable. And now I have the option to change the angle of the cross section. So let's make it 15 degrees. Click on OK. And sorry, let's let's choose a cross section over here and make it tapered. And that's really nice. So that's where I get the 15 degrees. So again, that's a little bit outside of our topic today, but I thought it would be nice to just see how the variable material is something that can show up in different categories in Revit. And the next question would be, all right, so where do we use this variable material? Because in the wall example, it was pretty clear, why do I need the variable material? I just want to expand the wall. I want to create a tapered wall. But Let's delete this one. But then what do I need the variable material for in landscape or in Toposolids? Well, I have to be honest with you. I usually do not like to use the variable material unless I need to. So if you can take a look at the types that I created for myself, I have every type with variable and without variable material. I don't know if you guys think it's a good idea or not. You're welcome to comment about that in the chat, but that's just something that I did. I think it's more convenient to have it like that, and you actually have the option. So the one thing that could be really convenient with variable materials is that you can actually create a tunnel, and it allows you to also calculate the volume of a certain material. So if we create a section box over here, let me just cut a little bit into these Toposolids so you could see clearly. The variable material itself is the one that's growing. So you have to be very thoughtful with which is the material that will grow, what is the material that you need to see the volume. So overall, you can see that we have the volume calculation for this Toposolid. It's 787,500 cubic meters. And now one thing that I could do with it, I could take this mass form or void form and actually create a tunnel with it. How do I do it? Let's go to edit in place and just turn it into a void form. Then let's go to cut, select the Toposolid, select the form, click on finish mass, and there we go. So we have a tunnel or whatever opening that we need to have, and then you can see that the volume of the Toposolid reacted accordingly. So this is one thing that we could use the variable material for, and it's very useful for that. So before Revit 2024, it is available only with floors, but now in Revit 2024, you can also do it with Toposolids, which means that first you can use environment topography tools to edit the finish face at the top of the Toposolid, and second, you can also see the contour lines over here. Another thing that sometimes I use the variable material for, or the Toposolid with the variable material type, is to create surveys, right? So if I have a CAD file for my surveyor, I will go to the Messingen site, Toposolid, create from import, and then I can choose my CAD file, select the layers with the contour lines, click on OK, and let's change this existing ground to a variable material. So in my opinion, getting the survey in this shape is a little bit nicer to start with my existing site. That's a little bit better for me. And usually when I model a survey, I would use the variable material. Now, there's another question, which is, what are the limitations? What are the downsides of using a variable material? So the one important limitation that you have to remember when creating a Toposolid with a variable material is that you would not be able to change the elevation of a point to any level that is lower from the original constraint. So I would not be able to go under, in this case, 0 sea level. If I would try to go, let's say, -1, I would immediately get this error that says slab shape edit failed. The floor or roof or Toposolid is too thin for its given type. So that's something that we have to keep in mind. We will not be able to edit our Toposolids or floors to an elevation that is lower than the original constraint we defined for the Toposolid. Although there's one specific case where Toposolids with variable materials are extremely important, and this is with roof gardenings. So if you guys were here in last week's session, you could see that this is very much the same example that I demonstrated on. And today I'm going to give you a short example of how we can use a Toposolid with a variable material to create an accurate model of a roof garden and actually be able to calculate the volume of the materials on this roof garden. So let's start with our example. The first thing that I have to do is to just create my Toposolid and place it on top of the roof garden. So you can see that I have my link, right? And I have this roof from the constructor or from construction engineer or from the architect. And if we go to the section view, you can see that this roof has all kinds of slopes. Now in this example, I made it a little bit extreme just for the sake of the example to be, you know, very, very obvious. So you'll understand why do I need to do that. A lot of times the slopes on these kind of roofs would be very mild, but they will still exist and they will still have an influence on the material takeoffs that we will get from the roof. So the first thing I want to do is to create my Toposolid in a way that will cover the roof. So let's go to Environment, Topography Tools, and let's select a type. I want to start with, let's go with the blue material over here. Click on Apply. And the next thing I'm going to do is I will edit the sketch just to give it a shape. So just for the beginning, it will be flat. It will be on the floor, on this sea level 0. Let's click on the green tick to approve the boundary. So we have a type, we have a boundary, and our Toposolid is actually going to be flat on the sea level. I'm going to finish for now. Don't worry, we will go back and edit that. And let's go to the section view. You can see that my Toposolid is here. So the next step, what I want to do is to raise it all the way to be cut by the construction roof. So let's go all the way up and take a spot elevation and see what is the elevation over here, 135.90, and over here 135.52. So I want the bottom of my Toposolid to be in the middle. Let's select the Toposolid and define the height offset from level to be 130, what was it, 6.5, I think. All right. So the most important thing for me is that the bottom of my Toposolid will be entirely cut within the construction roof. Again, this is a linked model, but I just want the bottom to be cut. So when I define a height offset from level, don't forget, I define the top of the floor. But what I care about right now is this one, is the bottom. So sometimes I might have to take it manually a little bit up or a little bit down, it doesn't matter. At this point, I'm pretty happy. And the next step would be to design the finish face of the floor. I get a question here from Alex, can I use the align tool? Yes, that's a great idea. You could definitely use the align tool. You could move it manually. You could just change the height offset from level. That's the first stage. We have the Toposolid, and now we have to design the finish face. So the second step of designing the finish face will be really the same as what I did last week. I'm just going to repeat the same thing. I'm going to select the Toposolid, edit it with environment topography tools over here, and again, let's go through the entire process really quickly. If you guys weren't here last week, then feel free to run the YouTube again. I'm just going to use the from edge tool to make sure that my floor, the top of my floor, or sorry, my Toposolid is connecting the entrances to the building. Let me delete these extra points. I'm going to go back to from edge, 1 point, and just connect it to the street. Insert points to make it a little bit more perfect in a way that I'll be happy with my contour lines. I'm going to use the slope path tool. First point, direction, second point. Let's say that I'm happy with the slope. I'm going to click on insert points, and now I'm going to use the insert midpoint in this case to just refine the Toposolid that I have over here. Make sure that the contours are a little bit more sharp or precise, what I intended them to be. So once I click on finish, don't forget that with Toposolids, using environment, we actually have these points as reference surface. They can be outside of the boundary, but the overall boundary I selected was this one. So let's click on finish and take a look at the 3D view. So the first step was to place my Toposolid at the correct boundary type and height. The second step was to define the finish face of my landscape. That's the top of the Toposolid. And the third step would be to subtract the volume of the roof from my floor. Now this is a little bit problematic because this roof is linked and it's not live in my model. So I'm going to show you actually two solutions how to do that. One of them I already showed in a very detailed video that I created in our YouTube channel a while ago, and the second I didn't show it yet, so it'll be nice to show you this trick. So the first and easiest solution will be to tab select the linked roof, and I'm going to now copy to clipboard and then go and paste a line to same place. Click on OK over here. You can see that I have this warning. All right, line and sketch is slightly off axis, but at the end you will see that we have two roofs, one on top of another, and I'll talk about how to solve that. But for now, let's just isolate these two elements and see what we have. So we have a copy of the designed roof, designed by the engineer or the architect, and we have our Toposolid. So the easiest thing to do right now would be to go to Modify and use the Cut Geometry option to cut the Toposolid with the roof. Let's isolate the Toposolid now so you could see how great this is. Now, if I do a material takeoff, I'm able to provide the accurate quantities of the material that has to be on the roof. But there is a downside to this method, because I don't want to have the construction roof in my landscape model. It's like having double the element, and that's not very much beam accurate. So now I'm going to show you a second trick on how I can subtract these quantities from my Toposolid in a more, I would say, beamish way, more accurately. So first, let's just go ahead and uncut the Toposolid. Again, I have a Toposolid and a roof, and I'm going to isolate only the roof element right now. And what I will do is, in short, I will export this roof as a solid to CAD, create a new in-place family, place this roof inside it as a void form and cut it from my Toposolid. And let's see how we do it. It's actually very easy. So the first thing, you have to isolate it entirely, and then go to File, Export, CAD Formats, DWG. Over here, there are two things that you have to make sure. The first one, let's click on this Modify Export Setup. What I want to make sure is that in the Solids tab, I'm exporting it as an ACIS Solids. I have to admit, I have no idea what this means. I just know that a mesh is not a solid. And what we're looking for is to have a solid that will cut our Toposolid. So again, you don't have to understand all the, software terms, but you just have to understand that a mesh is a surface without, a thickness. And if we want to create a Boolean operation and cut our Toposolid, we need to create a solid. So that's the first thing. The other thing is that in the units and coordinates for this method, it worked better for me to export it with internal origin as the coordinates base and not according to the shared coordinates. If you encounter something different, feel free to write in the comments and let us know what was your experience with this process. But in short, you just have to export as a DWG, make sure it's a solid, make sure it's within internal origin coordinates, and let's go ahead and export that. The next thing would be to save it somewhere in your computer, where mine is a complete mess. So I'm just gonna hide it in the side. Call it test, something with test, click on OK. And now Revit will ask you, do you want to turn on everything that's hidden in the view? And the answer is no. Leave the temporary hide isolate mode on and export, because I don't want to export everything in my model. I just want this tiny roof. So leave the temporary hide isolate mode on and export. And great, we have it exported. So I'm not deleting this roof yet. The next step will be to go to Architecture, Component, and then start an in-place family. It doesn't matter what category, but I'm just gonna go ahead and make it a roof family. Call it Toposolid, Void, or whatever seems good to you. Click on OK. And within the family editing mode, I'm gonna go to Insert, Import CAD, my mess. I'm gonna hide my mess, and I'm gonna select the one that I just created, but I have to show you my mess because please make sure to position it origin to origin and to mention the import units. So, all right, hiding it again. Click on Open, and you can see that it's here. How do I turn it into a void element? Well, that's very simple. I just have to go over here and click on Explode. And there you go. Now you can see that we have a solid, or we can change it to a void. Let's unhide now and use this void to cut it. Over here, I'm going to cut the Toposolid with my void, which is over here. Where is my void? A little bit of moving my mouse. There it is, void free form element. Click on this one, finish model. And at this point, I'm going to go back to the section and actually delete the duplicate roof. Let's go to 3D view and just isolate my Toposolid so I can see the result. And again, you can see that's the same result as the cut geometry that I used with the roof, but now I don't have the duplicate roof that I had before over the linked model. So I only have my original shape. All right, so that was this trick. We can now go to the section view and see how great it is that we are actually able to see the different materials and the different layers. And you can already imagine how a material takeoff would allow you to extract the quantities from this model. So this was today's topic. I hope you guys enjoyed it. I think if you have any additional questions, this would be the perfect time to ask them. If not, I want to remind you all that our website is arcintelligence.com and that you have a free trial of 30 days within our website, arcintelligence.com. There you have a free trial over here. You also have a very detailed user guide where Oded, my colleague, and I are working pretty hard to keep that up to date with tutorials and other instructions. So again, feel free to reach out to us. You have the contact us form over here. And I guess this is it for today. I promised to keep it short, light, and breezy, and I think I did it. So have a great evening, everyone.